questions 1 through 10 on the 2003 grade 10 AMC 10A. What is the difference between the sum of the first 2003 even counting numbers and the sum of the first 2003 odd counting numbers? So they want the difference. So this is a subtraction question between two large sums. The first sum is the first 2003 even numbers. So 2, 4, 6, 8, and so on. All the way up to which number? Well, it's the first 2003 even numbers, and an even number is of the form 2n. So n is, in this case, is 2003, so 2n is 4006. That's what it goes up to. So these are the first 2003 even numbers. I don't know why they put this word counting. And then the next set is the first 2003 odd numbers. So an odd number is of the form 2k minus 1, correct? So k in this case is again 2003. So we've got 1 plus 3 plus 5 plus 7 ... all the way up to the final one, which is k equals 2003 plugged into 2k minus 1. So that would be 4005. And there you go. This is what they want. Now obviously I'm not going to add them all up and subtract them. So there's an easy way of doing this. Take the first term of both sets and subtract those. Take the second term of both sets and subtract those. 4 minus 3, right? I'm just doing them in pairs. 6 minus 5, and so on. You get the point. 8 minus 7, like that. All the way up to the very last one, which would be 4006 minus 4005. And then let's see what you get. So for the first one, 2 minus 1 is 1. 4 minus 3 is 1. 6 minus 5 is 1. 8 minus 7 is 1. All the way up to the very last one, which will be 1. So they're all ones. How many of these ones do we have? Well, each of these pairs involved one number from this set and one number from that set. Each set had 2003 numbers. So we had 2003 pairs, and therefore 2003 ones. So the sum is basically 2003 times, and that therefore adds up to 2003. So number 1, the answer is D. Members of the Rockham Soccer League buy socks and t-shirts. Socks cost $4 per pair, and each t-shirt costs $5 more than a pair of socks. Each member needs one pair of socks and a shirt for home games, and another pair of socks and a t-shirt for away games. If the total cost is $2,366, how many members are there in the league? So we have socks that cost $4, and we have t-shirts that cost $4 plus 5, which is 9. And each person needs one sock and a t-shirt for home, and another sock and a t-shirt for away game. So each person needs 2 of these guys and 2 of t-shirts. So the costs will be 2 times $4, which is $8. And for t-shirts, the cost will be 2 times 18, which is 2 times 9, which is 18. So the total cost is $26 for each player. And then they're saying the total cost for the entire team apparently is $2,366. So if each player needs $26 worth of gear, 26 times, let's say the number of players is n, 26n will equal 2,366. And now to get n, you just divide 2,366 divided by 26, like that. And therefore n is equal to 91. So there are 91 members in this league. So number 2, the answer is B. A solid box is 15 by 10 by 8. A new solid is formed by removing a cube 3 centimeters on a side from each corner of the box. What percent of the original volume is removed? So you've got this box here, and from each corner you're going to remove a 3 centimeter cube. So first let's label this. Let's say this is 8 and this is 10 and this is 15. From each corner you're going to remove a small box that is 3 centimeters. So something like this. You're going to remove a little box like that. And that box basically has a volume, and if you add up those boxes, they want you to figure out what percentage of the original volume is removed. So first let's figure out the total volume of the solid box. So volume T, volume total, is 15 times 10 times 8. And that basically is 1200. Now from each corner you remove this 3 centimeter cube. So a cube has volume 3 times 3 times 3 if the edge is 3. So I'll put volume of cube, VC. So 3 times 3 times 3 is 27 for each of those cubes. Now, each corner has from it a cube size section removed. So how many corners are there? There's 8 corners. So the total amount removed is going to be 8 times 27. All right, which is 216. So now they want you to figure out 216 represents what percentage of the original volume. So 216 divided by the original volume, which is VT, total volume, 1200. And if you do the math here, you'll figure out that this is about 18%. So number 3, the answer is D. It takes Mary 30 minutes to walk uphill 1 kilometer from her home to school, but it takes only 10 minutes to walk from school to home along the same route. What is the average speed in kilometers per hour for the round trip? So speed is equal to distance over time. And in our case, the distance is 1 kilometer from her home to school, and then another kilometer from school to home. So her distance is 1 plus 1. Her time, 30 minutes to go from her home to school. So we got to do this in hours, right? Kilometers per hour. So the top was in kilometers. So 30 minutes in terms of hours is 30 over 60. And then we have to add an additional 10 minutes because that's how long it takes her to go from school to home. 10 minutes in terms of hours is 10 over 60. So there you have it. There is our equation. So we got 2 on the top and 40 over 60 on the bottom. Invert and multiply, so you get 60 over 40 like that. So this looks like 120 over 40, which is 3. And since we had our units as kilometers per hour, this is 3 kilometers per hour. And that is her average speed for the round trip. So number 4 is 8. So we've got solutions 2x squared plus 3x minus 5 is equal to 0. And they're saying that E and D are solutions, and what is the value of D minus 1 times E minus 1? So we just factor this. Maybe we won't need to use a quadratic. This will be 2x and x, and this looks like 1 and 5 positive negative. So that will, if expanded, it'll give you this. So therefore, just from this, we know that the roots are minus 5 over 2 and 1. So we can call one of these D. Let's call this one D, and we'll call this one E, like that. And they want you to figure out D minus 1 times E minus 1. So we'll sub in our values for D and E. Minus 5 over 2 minus 1, and then 1 minus 1. And since 1 minus 1 is 0, this will be 0. So there you go. Number 5, the answer is B. Define x heart y to be the absolute value of x minus y for all real numbers x and y. which of the following statements is not true? The best way to approach questions like this is to give some actual values for x and y, and then we can kind of look through the answer choices. Any values you want. So I'm going to choose a negative and a positive. That should be good enough because it'll give me kind of an understanding on both sides of the number line. So let's start with this. A, x heart y is equal to y heart x. All right, let's see. X heart y, if we use our definition, which is right there, would be minus 5 absolute value. And then y heart x would be 5 minus 5 absolute value. So this is minus 10 absolute value, and this is 10 absolute value. So 10 is equal to 10. So it looks like A is fine. Let's move on now to B. B is basically 2 times x heart y. So that would mean minus 5 root, like that. And it equals 2x, which is 2 times minus 5, heart 2y. So minus 2 times 5, like that. Absolute value. So let's see, the left side becomes minus 10 absolute value. And the right side looks like absolute value of minus 10, like that. So we got 2 times 10 times absolute value of minus 20, which is 20. And 20 does indeed equal 20. So it looks like B is correct. All right, let's move on to C. This guy right here. X absolute, x heart 0 is equal to x. So x in our case is minus 5. So we have minus 5 minus 0 is equal to just x. So minus 5. So minus 5 minus 0 is minus 5. Absolute value is equal to minus 5. The absolute value of minus 5 is 5. And does that equal minus 5? No. So C is not true. So number 6, the answer is C. How many non-congruent triangles with perimeter 7 have integer side lengths? So let our 3 sides be A, B, and C. And there is a rule for all triangles that the 2 sides, the sum, have to be greater than the third. That's the only way a triangle can be made. And we are told that the perimeter is 7. So that means that A plus B plus C is 7. So let's start making a table and see what we get. So let's give a value for C. Let's say it's 7. Now the perimeter is 7. So if C is 7, A would have to be 0 and B would have to be 0. Obviously that's not going to be a triangle. So that's no good. Let's drop the 7 down to a 6, see what happens. Well, the perimeter is 7, so this would have to be 1 and this would have to be 0. Obviously not a triangle. And remember, all the sides have to have integer side lengths. Let's keep going here. How about C equal to 5? Is there anything that works there? 1 and 1. Will that satisfy the perimeter requirement? Yes. Would you be able to make a triangle though? That's where this rule comes in. A plus B has to be greater than C. And that rule, unfortunately, is not satisfied, so that's no good. No problem, keep going. How about 4? If C is 4, the perimeter is 7, so, for example, 2 and 1. That would satisfy the perimeter requirement. But does this satisfy this requirement of A plus B greater than C? No, so that's not one of the triangles. So as you can see, it's more of a, let's work through this instead of having some very quick and fast way. How about 3? 3, we would be able to make, say, 3 and 1, or 3, 2 and 2. Those are ways to make the perimeter 7. How about the A plus B greater than C rule? Do they satisfy these? And the answer is they do. 1 plus 3 is indeed greater than 3, and 2 plus 2 is indeed greater than 3. So there you go. These are your triangles. Now, you can keep going here. Like, for example, C, make it 2, and you'll find you make this 3 and 2. You say, well, I got another one. A plus B is greater than 7 here. Yes, but it's the exact same as this one. They want non-congruent triangles. They want completely different triangles. See what I mean? And similarly, if you drop down to 1, you can get 3 and 3. And you say, well, look, that satisfies my conditions. Yes, but that's the same as that one. So if you really make the entire list and compare it backwards and forwards, you'll find that the only two possible non-congruent unique triangles are these ones right here. So the answer to number 7 is 2 of them. What is the probability that a randomly drawn positive factor of 60 is less than 7? So the first thing, of course, is we have to figure out the factors of 60. Before I do that, I will break it into its prime factors. 2 times 2 times 3 times 5. 4 times 15 would be 60. Now, using that, I'll list here all of its factors. So it's going to be a lot. 1, 2, 3, 4 because 2 times 2. 5, 6 because of 2 times 3. 6 times 2, which is 12. 3 times 5, which is 15. 4 times 5, which is 20. 2 times 3 times 5, which would be 30. And I think 60 is the last one. So as you can see, quite a few. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm probably missing one here. Let me just make sure. Oh yes, 10. You see the importance of checking because 2 times 5 is 10. So if you do this completely, you'll find that there's 12 factors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so 12 factors. All right, I certainly hope I didn't miss any. Now, what is the probability that if you randomly draw one of these numbers that it's going to be less than 7? Well, all of these are less than 7, right? And how many of them are there? There's 1, 2, 3, 4, 5, 6. So there you go. 6 of them are less than 7. Total number of factors is 12, and therefore that's the probability. And that, of course, reduces to 1/2. So 8, the answer is E. Simplify this expression. Okay, so I'm going to, of course, write this out in terms of fractions instead of root signs. So this little guy in here, write as a half, and it's multiplied by x, and it's all to the 1/3 multiplied by x, which is all to the 1/3, and multiplied by an x, and that whole thing is to the 1/3. All right, I hope you followed that. You got 1/3 here, 1/3 here, 1/3 here, so I've got 1/3, 1/3, 1/3, and then finally this is a square root, so I've got a half. So basically what I did is I just took the root signs and I've converted them into fractions. All right, in a very careful way, let's proceed with this. First, let's work on this guy here in the middle. This is really x to the power of 1. So if you multiply, you have to add those exponents. So this becomes x. 1 plus a half is 3/2. Okay? Everything else stays the same. Try to make sure that everything else stays the same here. The challenge in this question is miscopying or not miscopying, actually. Okay, so far I think everything is fine. And then let's proceed. Let's concentrate on this guy right here. So we now need to multiply those exponents. So this becomes x. 3 times 1 is 3 over 2 times 3, which is 6. So it would be 3/6, which is a half. All right, so just like that. And then everything else stays the same. This x is there, and then it's all to the bracket 1/3. This x is there, and that's all to the bracket 1/3. And again, in a very similar way, this is 1. So this expression, add the exponents. So 1 plus a half, x to the power of 3 halves, like that. Everything else stays the same. Don't forget to put that in brackets. And then this whole thing is in brackets. So we're moving along here. Now, again, let's concentrate on that guy. These exponents need to be multiplied, so we'd have 3 over 6. That is a half, so x to the half. X, and then that's all to the 1/3. Very similarly, that's x to the 1. Now you have to add these exponents, so 1 plus a half is 3 over 2. All to the 1/3. And we are almost done. 3 times 1 is 3, 2 times 3 is 6, so it would be 3 over 6, which is a half, so x to the half. And x to the half is essentially the square root of x. So that whole thing simplifies to the square root of x, which for number 9 is choice A. The polygon enclosed by the solid lines in the figure consists of 4 congruent squares joined edge to edge. One more congruent square is attached to an edge at one of the 9 positions indicated. How many of the 9 resulting polygons can be folded to form a cube with one face missing? So the shaded area right here, they are going to use for all the possible choices. And for each one, you're going to add one of these that's numbered from 1, 2, 3, 4, 5, 6, 7, 8, 9. So for example, let's start with 1. You're going to take this shape now and see if you folded it up, could it form a cube? Yes or no? Well, 1 is here. I'm going to put the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and then beneath each one I'm going to say yes or no. Can that be formed into a cube? So first we're dealing with 1. If 1 is added to that shaded area, it's really just a question of visualization. If you do, you'll notice that for 1, you actually will not be able to, because you'll have 2 tops. This will eventually become the top, and so will this guy right here. So, no. Why you'll have 2 tops? Any reason really, whatever reason you feel that a cube cannot be made. Okay, so 1 was a dud. So now let's move on to 2. If we use 2 with our shaded area, can we get a cube? And the answer is no, because see, 2 is stuck really to the other, so it really can't be separated. It can't be folded by itself. So the answer is no. I'll just put stuck. All right, so let's move on here. We got 3 now. Can 3 be made? And as you can see, I'm just purposely doing it slow, but you'll probably be able to do it much faster. How about 3? Can you make that shape that I've outlined in red into a cube? And the answer is no, you can't. Because if you tried, this guy and this guy would flap over each other. You'd have overlaps. So unfortunately, that doesn't work either. And now let's move on to just one more, because the rest I'll let you figure out instead of trying to visualize all this for you. How about 4? If you use that, can you make a cube? And the answer is yes, but only with one face missing, right? That's a very key to the question, because a cube, as everybody knows, has 6 sides. This is only 1, 2, 3, 4, 5 sides. So you'll be able to make a cube, but one face will be missing. So yes for 4. And very similarly, interestingly, it's a yes for every other one. Indeed. So that means of all of these, 6 of them you can use to make a cube with one face missing. And in your spare time, just visualize it, or if you really want, you can get a piece of paper, cut it out, and try that way. So number 10, the answer is 6, which would be choice E.